All right, guys, on this one we're told to use the limit comparison test. And what it basically says is, one of these two we know what it does. So let's hypothetically say b sub n is the one we know what it does. So if we take a limit as n goes to infinity, so we're basically looking at what's happening to the terms of these series, not this sum of the series, but the terms of the series. And if the terms are approaching some finite limits, so this means finite, it's some positive finite limit, then, and again, we know what this one does. So if it converges, then the other one converges. If this one that we know what it does diverges, and again, this is finite, then the other one diverges. Right? If we do get 0, notice this is strictly greater than 0, strictly positive, but if we do get 0 and one of them converges, one on the bottom converges, then the top also converges. All right, now they're telling us to do a limit comparison test here with 1 over n squared. Now 1 over n squared does converge. All right, that's a p-series with the power being greater than 1, so it converges. So I'm going to take this limit, the limit as n goes to infinity, and I always let the one that I know what it is be the one on the bottom. So 1 over n squared is going to be at the bottom. And I'm going to put this one on the top. So n minus 5 divided by n cubed plus 5n squared plus 4. All right, so that's the limit I'm going to take. But of course, I'm going to clean that up. I'm dividing the bottom fraction by flipping and multiplying. And then that's going to give me an n cubed minus 5n squared in the numerator. And then this is just think of it like x's. These have the same power. So this is like a horizontal asymptote, and this is the same limit that I would get if it only had those first terms. If n's going to infinity, then like none of these other terms that are lower powers even matter, and this is just the limit as n goes to infinity of 1. N cubed divided by n cubed is 1, so that has a limit of 1. 1 is between 0 and infinity. This one converges, so that means a sub n also converges. So this thing converges by a limit comparison test with 1 over n squared.